According to National Electrical Code Section 645.15, uninterruptible power supply, or UPS, systems used in data processing systems, or D3 systems, are generally required to be isolated from ground. This means the UPS should not have a direct electrical connection to earth or to the neutral conductor. However, there are a few circumstances where grounding may be allowed. Firstly, equipment bonding. If the equipment connected to the UPS is grounded, the UPS system may also be grounded to provide a common reference point. This is typically achieved through a bonding conductor connected to the equipment ground bus. Secondly, lightning protection. In areas with high lightning activity, grounding may be necessary to protect the UPS system from lightning surges. Thirdly, electromagnetic interference, or EMI. Grounding may be required to reduce EMI emissions from the UPS system. This is typically done through a shielded grounding conductor connected to the system's chassis. For Modicon UPS systems, Schneider Electric, the manufacturer, recommends isolated grounding for their UPS systems. However, they also provide the following guidance. For Modicon TSX UPS systems, grounding should only be considered in exceptional cases and under the guidance of a qualified electrician. For Modicon Unity Pro UPS systems, grounded operation is not recommended and should only be used if absolutely necessary. There are benefits of isolated grounding. Isolated grounding reduces the risk of ground loops and electrical noise. Isolated grounding also improves system stability and reliability. Isolated grounding also protects equipment from ground faults. There are also disadvantages of grounded operation. Grounded operation can create ground loops and electrical noise. Grounded operation may compromise the UPS isolation capabilities. In general, it is best to follow the manufacturer's recommendations and isolate the UPS system from ground. However, there may be specific circumstances where grounding is necessary. In such cases, it is crucial to consult with a qualified electrician to ensure proper grounding and to minimize any potential risks. It's important to understand the implications of both grounding and not grounding a UPS system to ensure the safety and reliability of the connected equipment and the overall system. When making decisions about grounding, consider the specific requirements of the equipment being powered, the environmental conditions, and any applicable regulations or standards. Also, remember to consult with qualified professionals to ensure that all work is performed safely and in compliance with local codes and regulations. Grounding and bonding are critical aspects of electrical safety, and it's essential to have a thorough understanding of the principles involved. The NEC provides guidance on grounding and bonding requirements, but it's always best to consult with a licensed electrician or electrical engineer to ensure that your electrical system is properly grounded and bonded. Ground loops are a common problem in electrical systems, and they can cause a variety of issues, including noise, interference, and equipment damage. Ground loops occur when there are multiple ground paths in a system, creating a circulating current that can interfere with sensitive electronic equipment. Isolated grounding can help to prevent ground loops by providing a single, dedicated ground path for the UPS system. EMI is another concern in electrical systems, and it can be caused by a variety of sources, including power lines, radio transmitters, and electronic equipment. EMI can interfere with sensitive electronic equipment, causing it to malfunction or fail. Grounding can help to reduce EMI by providing a path for the EMI to be dissipated to ground. Lightning strikes can cause significant damage to electrical equipment, and grounding can help to protect against lightning surges by providing a path for the surge to be dissipated to ground. The grounding conductor should be sized appropriately to handle the expected surge current, and it should be connected to a grounding electrode system that is properly installed and maintained. The equipment ground bus is a critical component of the grounding system, and it provides a common reference point for all of the grounded equipment in the system. The equipment ground bus should be sized appropriately to handle the expected fault current, and it should be connected to the grounding electrode system. The grounding electrode system is the connection between the electrical system and the earth, and it provides a path for fault current to flow back to the source. The grounding electrode system should be installed in accordance with the NEC, and it should be inspected and maintained regularly to ensure that it is functioning properly. When grounding a UPS system, it's important to use the correct type of grounding conductor. The grounding conductor should be sized appropriately to handle the expected fault current, and it should be made of a material that is suitable for the environment in which it will be used. Copper and aluminum are common materials used for grounding conductors. The NEC provides guidance on the proper sizing and installation of grounding conductors. It's important to follow these guidelines to ensure that the grounding system is effective and safe. In addition to grounding, bonding is another important aspect of electrical safety. Bonding is the process of connecting all of the metal parts of an electrical system together to create a common electrical potential. Bonding helps to prevent shock hazards by ensuring that all of the metal parts of the system are at the same voltage. The NEC provides guidance on bonding requirements, and it's important to follow these guidelines to ensure that the electrical system is properly bonded. When working with electrical systems, it's important to always follow safe work practices. Always to energize the circuit before working on it, and always use appropriate personal protective equipment, or PPE, such as gloves and safety glasses. It's also important to be aware of the potential hazards associated with electricity, such as shock and arc flash. Arc flash is a dangerous phenomenon that can occur when there is a short circuit in an electrical system. Arc flash can cause severe burns, and it can even be fatal. The NEC provides guidance on arc flash safety, and it's important to follow these guidelines to protect yourself from arc flash hazards. Before working on any electrical equipment, it is crucial to ensure that the power is turned off and locked out to prevent accidental energization. This process typically involves using a lockout/tagout procedure, where the circuit breaker or disconnect switch is turned off and a lock and tag are attached to prevent it from being turned back on. This ensures that the equipment is safe to work on and reduces the risk of electrical shock. Proper grounding and bonding are essential for maintaining a safe and reliable electrical system. By following the guidelines outlined in the NEC and consulting with qualified professionals, you can ensure that your electrical system is properly grounded and bonded, reducing the risk of electrical hazards and improving the overall performance of your electrical system. In addition to the NEC, there are other standards and regulations that may apply to UPS systems and grounding. These standards may vary depending on the location and the specific application. It's important to be aware of all applicable standards and regulations to ensure that the UPS system is installed and operated in compliance with all requirements. Regular maintenance and testing of UPS systems are essential for ensuring their continued reliability and performance. Maintenance should include visual inspections, cleaning, and testing of the batteries and other components. Testing should include load testing to verify that the UPS system can provide the required power during an outage. Proper maintenance and testing can help to identify potential problems before they cause a failure. When selecting a UPS system for a computer system, it's important to consider the specific requirements of the equipment being powered. This includes the power consumption, voltage requirements, and any other special requirements. It's also important to consider the reliability and redundancy of the UPS system. For critical applications, it may be necessary to use a redundant UPS system to ensure that power is always available. The use of isolated ground systems can minimize the impact of electrical noise on sensitive electronic equipment. Isolated ground systems are designed to prevent ground loops, which can introduce noise into the system. These systems typically involve using a separate grounding conductor for sensitive equipment, which is isolated from the main grounding system. This helps to reduce the amount of noise that is coupled into the equipment, improving its performance and reliability. When dealing with sensitive electronic equipment, it's essential to consider the potential for electrostatic discharge, or ESD. ESD can occur when there is a buildup of static electricity on a person or object, and it can damage or destroy sensitive electronic components. To prevent ESD, it's important to use proper grounding techniques and to wear appropriate ESD protective clothing, such as wrist straps and conductive shoes. Power quality refers to the characteristics of the electrical power that is supplied to equipment. Poor power quality can cause a variety of problems, including equipment malfunction, data loss, and reduced equipment life. UPS systems can help to improve power quality by providing a stable and clean power source. They can also protect equipment from voltage sags, surges, and other power disturbances. When selecting a UPS system, it's important to consider the power quality requirements of the equipment being powered. Transient voltage surge suppressors, or TVSS, are devices that are designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power line switching, and other events. TVSS devices work by diverting the surge current to ground, preventing it from damaging the equipment. It's important to install TVSS devices on all critical electrical equipment, including UPS systems. Harmonic distortion is a type of power quality problem that can occur when nonlinear loads, such as computers and electronic equipment, draw current from the electrical system. Harmonic distortion can cause a variety of problems, including overheating of equipment, reduced power factor, and increased energy consumption. UPS systems can help to reduce harmonic distortion by providing a clean and stable power source. Power factor is a measure of how efficiently electrical power is being used. A low power factor can result in increased energy consumption or reduced equipment life. UPS systems can help to improve power factor by providing power factor correction. In addition to UPS systems, there are other power quality solutions that can be used to improve the performance and reliability of electrical systems. These solutions include harmonic filters, voltage regulators, and surge suppressors. The best solution for a particular application will depend on the specific power quality problems that are being experienced. When designing and installing electrical systems, it's important to consider the impact of the system on the environment. This includes minimizing energy consumption, reducing waste, and using environmentally friendly materials. UPS systems can help to reduce energy consumption by providing a more efficient power source. They can also reduce waste by preventing equipment failures and extending the life of electrical equipment. In order to ensure the safe and reliable operation of electrical systems, it's essential to comply with all applicable codes and regulations. These codes and regulations are designed to protect people and property from electrical hazards. It's important to stay up to date on the latest codes and regulations and to follow them carefully when designing and installing electrical systems. The NEC is a comprehensive set of guidelines for electrical installations, and it's widely used in the United States. However, there are other codes and regulations that may apply in specific locations. It's important to check with local authorities to determine the applicable codes and regulations. Proper training is essential for anyone who works with electrical systems. Electricians and other electrical professionals should receive comprehensive training on electrical safety, grounding, bonding, and other important topics. This training should be ongoing to ensure that they stay up to date in the latest technologies and techniques. Electrical safety is everyone's responsibility. By following safe work practices and complying with all applicable codes and regulations, we can help to prevent electrical accidents and injuries. It's important to be aware of the potential hazards associated with electricity and to take steps to protect ourselves and others from these hazards. In summary, grounding UPS systems for computer systems, especially D3 systems like Modicon, requires careful consideration of several factors. While NEC Section 645.15 generally mandates isolation from ground, exceptions exist for equipment bonding, lightning protection, and EMI reduction. Manufacturers like Schneider Electric recommend isolated grounding for Modicon UPS systems, but specific cases may warrant grounding under the guidance of a qualified electrician. Isolated grounding minimizes ground loops and electrical noise, improving system stability and protecting against ground faults. Conversely, grounded operation can create noise and compromise isolation. Therefore, adhering to manufacturer recommendations and consulting experts is crucial for ensuring proper grounding and minimizing potential risks in each unique situation. The information provided here is intended for informational purposes only and should not be considered as professional advice. Always consult with a qualified electrician or electrical engineer before making any decisions about electrical systems.